Welcome to the next installment in the AUS Department of Architecture lecture series. The lecture tonight is actually the second lecture of the year that's sponsored by Arata Development Corporation, who are sponsoring our 401 studio, in which we're building a small pavilion in the Al Jada housing and urban development next to the university. So thanks to Arata for sponsoring the studio and for sponsoring the lecture tonight. We invited Erik L'Heureux here from Singapore because of his design expertise and knowledge and research that he's built up over the years in architecture that deals with tropical climates and the sort of equatorial south of the globe. Erik is a associate professor and the vice dean for special projects at the National University in Singapore. And he's also the principal architect and founder of Pencil Studio, which he runs as a design practice in parallel with his teaching. So I think it's, again, one of the maybe few practices in Asia in a really kind of capitalist and corporate society in Singapore, which is really academically and intellectually focused on the work. And I think through the work that you'll see Erik present tonight, you'll see a link between what he's working on at NUS with his research and with his teaching and what he's been doing in his practice. Erik was also the recipient of the Wheelwright Prize, which is a significant prize from Harvard University that funds extensive travel around the globe around a specific subject. So Erik won in 2016 or 15, and spent a number of months kind of working his way around the globe, again looking at 20th century architecture along and around the equator that deals with climate in interesting ways. His work, design work and design research has been awarded a number of prizes, including the Society of American Registered Architects, prizes from the World Architecture Festival, and a President of Singapore Design Award, among many others. He's a graduate of Princeton University and Washington University in St. Louis, and then moved to Singapore about 15 years ago for a duration of, thought he was going to stay for 6 months and ended up staying for 15 years. So I think it's really a great pleasure to have him here tonight and to think about how the work that he's been doing in Singapore, the work that's been published in his book, which is called Deep Veils, and a publication that he edited for some years called Hot and Wet out of NUS, all kind of relates to themes that we're thinking about in our studio in the design of our pavilion, thinking about a hot and dry climate. So without further ado, thanks and welcome to Erik L'Heureux.
Thank you. I'm delighted to be here at the American University of Sharjah to share a little bit of my work and thinking. So I want to extend a great thanks to the university and Arata Development for sponsoring this evening's event. Let me begin Hot Air, and the title of this lecture, with a quote from the founders of the Department of Tropical Architecture. Maybe you haven't heard of that, but I would encourage you to look it up. And they were Maxwell Fry and Jane Drew. In 1956, they said the rapid increase in population over the area of the tropics presents itself to the world as a problem of utmost gravity. What was a pressing concern over 60 years ago has become an issue of critical, if not dire, importance today, as a large portion of the world's growing population occurs in the equatorial region, and the resulting urbanization, dramatic territorial transformation, and even rising temperatures are altering the equator in substantial and unforeseen ways. Operating in the hot and wet atmosphere that I do, as opposed to the hot and dry here in Dubai, even though it seemed to have rained today, demands an entirely different set of architectural strategies from the temperate, which I argue is more or less where architecture with a capital A kind of began, or at least in the Western European sense, is where it occurs. The architecture on the equator is leaky rather than sealed. It is dark rather than light. It is deep rather than thick. It is perforated rather than closed. I'm going to show a few projects that I've completed in Southeast Asia that take on questions of atmosphere, urban density, and perceptions, kind of around what Jason just noted, a kind of deep envelope. And I was happy to see in his studio the title Thick Skins, I believe, which was from last semester that he taught. I moved to Singapore in 2003, that infamously small city-state on the equator, an Asian city washed from its gritty Oriental stereotypes, an Asian light experience for expats, and a perfect place for me to get out of my American myopia. With my arrival, I was struck by a particular equatorial conundrum, being that the buildings of Singapore, by and large, appeared the same from temperate origins. Sheathed in prophylactic glass skins, transparent, and symbols for a business-friendly and open state. Yet the architecture is located in a climate of ubiquitous heat, humidity, and rain, a climate that drives people indoors rather than out, under the covered rather than the exposed, and toward the artificially conditioned rather than to a monsoon breeze. Singapore's architectural scene in much of the developing tropics today is entirely dependent not only on air conditioning, glass curtain walls, and enclosed environments, but more precisely on an entire mindset of the eradication of the tropical. The city's skyline has been created by a collection of temperate masters. We see Kenzo Tangi in the back here, Caesar Pelli, KPF, this is NBBJ, another KPF, and Denton Corker Marshall on the far left. A city that could be anywhere except, surprisingly, in Singapore herself. What had been once permeable and ventilated, we might think of colonial black and white bungalows with deep verandas, large overhangs, and living raised on an open base, or buildings from the 1950s and 60s with jolly walls, brise-soleils, and deep recesses, where the passive devices of overhangs, high ceilings, perforated clear stories, open balconies, internal courtyards, and screens, in essence the calibration of architecture to the equatorial climate, have been replaced by new symbols of technology and progress. Sealed in hermetic envelopes powered by mechanical technology and cheap energy to condition air has systematically replaced architectural intelligence with a mechanical one. The history of climactic erasure in Singapore can be traced to the very particular developmental strategies of the city-state and the political will of Singapore's infamous leadership. The story goes like this. On the cusp of Singapore's independence from British colonial rule in 1963, the Prime Minister realized one of the most endemic issues was that if the tropical was going to perform and to develop, then Singapore herself had to be made to appear temperate. The logic goes that if Singapore looked like a city in temperate Europe or America, we could think of New York or Chicago or London, and felt the same on the interior, so too would Singapore reap similar economic benefits. In an almost Koolhausian retroactive manifesto, Lee Kuan Yew, who was the prime minister at the time, stated later in 1999, "Air conditioning was the most important invention for us, perhaps one of the signal inventions of history. It changed the nature of civilization by making development possible in the tropics. The first thing I did upon becoming prime minister," imagine the first thing that he did when he became prime minister of an independent state, was to install air conditioners in the buildings where the civil service worked. He says this was the key to public efficiency. The aspirational goals for the nation-state were then manifest through temperate, crystalline modernism, in its celebration of technology over nature, in the embrace of industrialization and machine precision, as a symbol that Singapore too had made it to the developed and, more importantly, temperate world. Today, much of the developing equatorial region suffers from similar aspirations, and in so doing decapitates itself from its own atmospheric context, erasing the knowledge that architecture not only can modulate climate as powerful as technology, but can also embolden the experience of space and the city itself. In short, equatorial architecture has forgotten its own form of spatial and climactic agency. The fondness for the temperate, as we saw in the previous slide by Mies van der Rohe's Friedrichstraße project, and manifest in Lee Kuan Yew's own predilection for air conditioning, can be traced as far back as Aristotle, where in his text Meteorologica, he describes the equator as a torrid zone, believing that the area was too hot for inhabitation. Such assumptions were embedded in architectural discourse from the very beginning, where Vitruvius states, "Those who live near the equator and are exactly under the sun's course are, owing to its power, low in stature, of dark complexion, with curling hair, black eyes, weak legs, deficiency in the quantity of blood," and the pejorative stereotypes go on and on. For much of the architectural world, the temperate was the habilitas, or habitable. And if you look closely, you see walled cities in the bottom here, churches, homes, while the tropical zone, the inhabilitas, it's no wonder that it's rendered as a kind of blank white zone. Even the Arctic here gets more articulation than the torrid. Or here in the hemispheric maps of Marcobulius from the 12th century AD, illustrating the uninhabitable world of the torrid as a red, fire-like center. Or even here from the maps of Alexander von Humboldt in his isothermic classifications, crudely classify the equatorial zone in one large, undifferentiated pink zone, yet we see Europe and America in a nuanced and fine-grained layers of articulation and stratification. If the original temperate manifestations of the equator was based on a generalized pejorative stereotype and a kind of outright fear of the hot, and an equally problematic stereotype emerges during the height of colonialism, one built on excess, plentitude, and fantasy. Illustrated by temperate painters such as Marion North or Franz Wilhelm Junholm, who were exploring the tropics in their respective tours, we find a landscape of luscious green vegetation, fruit so ripe they are splitting open, and a manicured landscape of illuminating greens and turquoise blues. Such paintings not only render the equatorial accessible to temperate eyes, but more insidiously transform the equatorial into a temperate vision. And of course, we see a nice manicured lawn inhabited by some colonialists on the bottom. It's no wonder that when we search for images, in this case of the Singapore Botanical Garden today, one of the main images in the Google search is a landscape of an almost temperate-looking yellow-leaved tree, as though fall is about to start, foregrounded with a manicured lawn, white gazebo, and a nice blue sky, closer in aesthetic sensibility to Kew Garden, England, rather than to what might be found on the equator. Or here in the etchings of Alfred Russel Wallace, we see the oscillation between one of pestilence and fear on the left. Yes, the imagination is that the equator can eat you. And the second, where the equator is a space of plentitude and leisurely tropical fantasy, ripe for extraction. So if the dialectics between the stereotype of plentitude and a dreamy idleness of the tropical atmosphere that we see illustrated in George Orwell's Burmese Days, which Lee Kuan Yew fought so hard against, and the energy dependence of climactic decapitation enabled by air conditioning that supposedly made the tropics possible, or made development on the tropics possible, what might then be an architectural expression of the tropical that confronts its dense urban reality, an expression that avoids the oppositional characteristics between natural ventilation or air conditioning, that merges ornamentation and performance together in a sensibility that is both open and closed, tropical and comfortable, local and aspirational. So I began to reconcile this kind of conundrum of equatorial amnesia by returning to a wonderfully inventive history of tropical calibrated architecture in mid-century modernism, mid-20th century modernism. I returned to the canonical text, Tropical Architecture in the Humid Zone by Maxwell Fry and Jane Drew, and the biblical-like Manual of Tropical Housing and Building by Otto Koensberger, who actually was the planner who gave Singapore her ring city concept plan. It's a kind of another story, but if you're interested in Singapore, I would look it up. Both texts are primarily based on climate control, suggesting a variety of technical and passive solutions after their respective return from Nigeria and India. The work is primarily small, object-like, low-rise, low-density buildings situated in jungle-like settings. This is a language of space and horizontal distance as the key driver of climate control. So climate was produced because the buildings were apart from one another. So we could say it's done through atomization, where maximizing the distance ensured that they were properly cooled and that acoustics and privacy was firmly controlled, given that the envelopes were by and large permeable. Large, low roofs with extensive overhangs, deep exterior spaces, any buildings of a single story predominate. Today, the challenges are very different in the hot and wet environment of Southeast Asia. The buffering open space traditionally between buildings has been consumed by denser urban environments. Verandas have all been eliminated by floor plate efficiency demands and calculations for GFA. High plot ratios and increased building heights have displaced the architectural and climatic role of the overhang and the roof to that of the elevation. So in Singapore, the primacy of the elevation takes hold, where the vertical plane rather than the horizontal is the crucial architectural element and the primary site of architecture's calibration to climate. We can find the elevation as a primary element in a fantastic collection of mid-century buildings from the 1950s to the 70s, produced right at this advent of air conditioning, where passivity and mechanical demands had equal sway to the architectural body, where atmospheric calibration was manifest through materials, not through mechanical conditioning alone. The work, for me, represents the best of architecture in the urban tropics, a modernist language adapted to context, prioritizing shade, opacity, and materiality over transparency and dematerialization. These are heavy buildings, opaque, and they belong on the equator. We can find lineages not only in Singapore, but in the general architectural discourse of the time, from Edward Durlstone's U.S. Embassy in New Delhi from 1955 to Vladimir Osipov's IBM building in 1962 in Hawaii, to Hassan Vogel's Sequoia Center in Jakarta from 1973. Likewise, the big, heavy, opaque roof found in Leandro Locasen's Cultural Center of the Philippines inspires my work, as does the International Trade Fair Complex from 1967 in Accra, Ghana, where the roof becomes an expressive element of exhausting hot air laterally. Or the recently burned but still amazingly market by Thomas Karsten, the lovely Paso Johar in Semarang, Indonesia from 1932, where the big roof ventilates and illuminates vertically as well as laterally. And this was before the Frank Lloyd Wright Johnson Wax building, if you see the kind of parallels. Or the first modern cast-in-place building in India, the wonderful Galkon Dormitory in Pondicherry from 1942, where a dramatic fiber-reinforced concrete louver system modulates climate between two courtyards, and a double-layer roof mitigates heat gain on the roof. My work has tried to learn lessons from these projects that prioritize the elevation as a site of architectural invention, however, transformed with new technology of simulation and digital fabrication, while confronting the ever-increasing densities of the context of Southeast Asia. I'm going to show 5 projects to give you a kind of sense of how I wrestle with context, climate, atmosphere, and aesthetics in an equatorial locale. And maybe the work that you'll see in the subsequent slides could be positioned between the reductiveness of Solowitz's wall drawings on the left and the kind of attention to pattern and field as we might find in Indonesian batik, where hierarchy, differentiation, and individuality are repressed, creating a kind of different aesthetic sensibility from the drawing on the left. And I'm interested in this kind of contrast. So the first project I'm going to show is for a house located, shows 3 houses and two mid-scale buildings. The first project I will show is for a house located in the southern shore of Singapore in a curious American-planned high-density suburbia with close building proximities. These houses are only 2 meters apart, kind of wall to wall. In this project called Stereoscopic House, I asked 2 questions. How can the envelope be used to test the relationship between building and its hot and wet climate? Can the envelope perform thermally as well as optically? It was commissioned by 3 older single Singaporean Chinese sisters, all in their 60s and 70s, one sister's son and a child. They were kind of brave to hire some curious American guy. But anyway, located on the flat reclaimed landscape of Sentosa Island, the stereoscopic house is sandwiched between an ocean view and a golf course view, and 2 neighboring units on the left and right. The architecture manipulates the relationship between atmosphere, water, landscape, and view through 4 levels of optical and thermal calibration. And because the site is very tight, the building is stacked. It looks like a 2-story building, but in fact it's 4. A basement plinth contains various support functions of the house. Here is a central courtyard that runs through the house vertically and allows for ventilation. And a lift core, because one of the sisters was in a wheelchair, links the 4 levels. This is the lift core top. The main living level, situated on the top of the plinth, is surrounded by translucent channel glass and transparent sliding windows, while the western elevation is primarily closed, though operable. And you can see that lift core popping up as though it's a kind of chimney. The eastern elevation is more transparent, though set deep within the building volume. When so desired, the entire wall can be opened, allowing the inside to transform into an exterior space, allowing a panoramic view, yet being protected by the overhanging tube-like volume above. The roof is angled and pitched, demanded by roof codes, and there are large verandas on both elevations. You can see that here, all the way cutting in. There's the courtyard and another veranda on this side. There are 5 bedrooms. It's a big house. Though they are isolated from the adjacent neighbors, they really look on to the center of the house rather than to the outside, while framing a dramatic view to the ocean in a stereoscopic manner. 2 bedrooms look out to the sea, while they face each other to a center courtyard. So this is 1 bedroom with the doors open, and we're looking out into a courtyard which actually extends much deeper into the architecture, and there's the other bedroom. There it is on the attic, a dramatic framing of a view of the neighboring islands from the 3rd-story guest bedroom. It also overlooks that elongated terrace here, but more than a terrace, what it is a thermal funnel, which allows the cool breezes that come off the ocean in the afternoon to basically be sucked into the architecture and down into a courtyard all the way into the basement. This terrace surrounds this courtyard and is veiled above, which you can see in a perforated roof screen that dapples dramatic light to below. There is a view of that thermal straw and the courtyard that goes down, and a view looking up from the basement up through the 4 stories in a kaleidoscopic play of reflection and screen as stack effect as a cooling device is at the heart of the design. And you can see how that works here as a kind of figure in the center of the architecture. A veil of 30 by 80 millimeter ironwood timber merges the roof side elevations and ceiling of the upper levels of the house in response to the tropical climate of Singapore, and an air gap between this timber layer and an internal waterproofing membrane minimizes the thermal transmittance to the building while allowing for rainwater runoff. In this case, the envelope ventilates, it leaks, and it breathes through its surface. The herringbone pattern is coupled with the timber's ability to age to a silver tone, amplifying its ability to reflect solar radiation while resisting the ideas that everything must be perfectly clean, a very Singaporean trope. Indeed, the house stains, it patinas, and ages as it confronts its climactic context. We could say the building form recalls the black and white colonial bungalow, shielding the first story, putting it into shadow. While operable aluminum screens allow the house to oscillate between screened and transparent, closed and open, sealed and ventilated. In addition to the lift core, there's a series of skylights that pop up. Together, these protrusions not only facilitate natural daylighting, but also create a phenomenological experience of light and shadow. Maybe that is unique to the home, and maybe they suggest, again, Solowitz's drawings from 1982. There's also these light scoops in the basement, a series of trumpet-shaped that bring reflected light to the lower level. The complicated forms were digitally modeled and fabricated off-site, digitally hot-wired cut in expanded polystyrene, then cast in place and manually chipped out. The resulting skylights punctuate the basement plinth in a collection of threes. This is on the stair, creating a dramatic atmosphere of hazy light. A screened car porch and translucent western elevation conceal the inhabitation of the house, so the western where you enter is very opaque in a way, kind of concealing it from the street and also minimizing the western sun load that is found in the Singapore afternoon. The low-E glazing, solar hot water heating, and rainwater collection systems are all in the house, though they're rendered discreet and invisible, yet combined with the tropical veranda and the Singapore shophouse courtyard in a form of environmental function. I think the result is an architecture of passivity that doesn't fall into typical gadget-like traps of environmental architecture and reasserts the ability for atmosphere as a primary driver for the design. For the next project I'm going to show, which I call Hut House, I ask, how can the elevation be the entire surface? Can it be reductive to the point that it is only the elevation as the architectural body? The architecture's simple volume adds to and extends a series of pavilions in a multi-generational residential plot in Singapore, surrounded by dense jungle-like foliage. It's a small addition to an existing colonial black and white, which I showed in the earlier slides just here, built right out to the plot line, and uses an envelope that's a transformation of an aluminum metal mesh folded in plan as a continuous surface, and I'll show you that in a second. The design engages a relationship between old and new, jungle and architecture, object and field, and you can see the original building. This is actually originally the servants' and kitchen quarters to the black and white house. We've added this little piece that kind of sticks onto it. This approach alludes to a primitive hut, a contrasting object to reinforce the difference between architecture and landscape, interior and exterior, natural and artificial. The pattern across the facade is layered on the horizontal axis and slightly folds, you can see it, as it kind of ripples, and covers windows alike, rendering the architecture as almost a kind of toy, or a toy in terms of its scale. And the roof profile is consistent with its neighbors. It has a similar scale of aggregation, and yet it differentiates itself really through the elevation. You can see this folding pattern here. And it gives a kind of uniformity and yet reflective quality. This is a simple expanded aluminum mesh. It's powder coated. And there's just, you can see there's little red arrows on here where we were marking it up and testing it in terms of, oh, there's the arrows. Testing it on how it would perform in relationships with solar radiation, while also allowing a view out. There are 4 protrusions, 2 for entry and exit, 1 skylight, and 1 of an unobstructed view to the jungle beyond, in a form that appears to be stretched and pulled, and I'll show you this one in a second. So you can see here those protrusions. There's 4 of them. There's 1 more. There's the one on the skylight. And here's the one that's kind of stretched and pulled or torqued to frame a beautiful tree. There it is a little bit better. Limited site areas and close setbacks. So there was a whole bunch of regulations about where the limits of where we could build, kind of forced the chamfered volume. On the lower level, a bedroom and living room extension are on the ground floor, and a painting studio and gallery are found on the 2nd story. So moving around the hut, each elevation takes on a different quality, from idealized hut form to frontal elevation to a chamfered peak. Within, the spaces are in a kind of dramatic natural light quality, ideal for painting, and the radius details of the exterior are kind of brought into the interior. There's a skylight that illuminates the center of the hut, creating a dramatic, almost bleaching white light, specific to living on the equator. I'm sure in Dubai you have a kind of similar quality, or at least I sensed it today. But more importantly, creates a kind of diffuse light needed for painting. I mean, the painter really liked that. I mean, he didn't want it to be cut or shielded. He wanted it to be as bright as possible. The very quality of equatorial light coming through the skylight gives presence to the color and texture of his paintings, and for the studio. For me, equatorial light is not something just to eliminate, but something to engage in, play, and work with as mediums of the atmosphere, as fundamental to our context. From within, there are screens that allow views and ventilation between the rooms, linking the original house to its newer addition. We did daylight studies to ensure that there was enough deep penetration on the lower level. This small hut is shielded also in a series of kind of envelopes, and I would argue that one is also the jungle-like envelope around it. So not only do we have a screen, but we also have the kind of natural landscape. And I'll just give an anecdote that when this project, when people were looking to publish it, the publishers kept asking to remove the trees out of the photograph, right? As though the jungle needed to be taken away. I think it's actually a deeply temperate sensibility, as though the house must be on a manicured landscape. And it makes visible to me that, in a way, the publishing of architecture doesn't always get it, or that it's constantly reinforcing a temperate sensibility. For them, they miss the point that the jungle is part of the architecture. The hut house is small and large, a little hut with a big scale. It works with reduction, obviously, as an architectural concept, a reduction of materials, tones, and configuration to amplify the interplay of architecture in the presence of the equatorial jungle. The next project, a simple terrace house, which I finished, must be about a year and a half ago, is one of those projects that architects like to avoid because it's in the middle, it's a mid-block. It's not ideal for normative forms of architectural photography that prioritize the corner. It's located in a Windsor Park neighborhood of Singapore, and it's composed of 2 pitched concrete forms containing private bedrooms and an attic terrace. and there's a continuous aluminum screen that wraps these volumes. It takes on a particular zoning requirement in Singapore that the pitched roof form, you can see it here and you can see it over here, for any new development, it must have a 45-degree pitch, at least on one of the elevations. And rather than becoming a kind of problem that you hide, it becomes an asset to the architecture. And it so mimics the houses in the foreground, yet becomes exaggerated and attenuated as a kind of dramatic roof profile. As I mentioned, the house is sandwiched between two houses left and right, and this reductive quality of the party wall mimics and extends the kind of urban context. There's an open-air courtyard, like we saw in the first house, that bifurcates the home, linking interior to the exterior air. And it folds in kind of section like this. So this is the courtyard. And the house is completely openable. It means you can never close it. It's always getting fresh air into the center of the architecture, even with air conditioning. You cannot seal the house. It's a view of the entry. A dramatic kind of cantilevered canopy protects it from rain, and then it's fully cross-ventilated on the ground floor from end to end. And here on the roof is the roof terrace, and here's the owner. And the air basically, it comes in through here and then down through the funnel or the courtyard, and it doesn't allow for rain to go into the inside. It's simple and graphic, with the hopes that concrete stains and mildews and accretes with algae on the side elevations as a resistance to the continual painting and power washing that manicures Singapore. So here's that courtyard. So this is always openable. There is a little bit of air conditioning, and I'll talk about it in a second, on the ground floor, but you cannot seal it. There's no way to get rid of the outdoor environment. So air conditioning in this case is thought of as a hybrid, not as a replacement to outdoor air. Rather, it is only used to reduce humidity levels when needed. And comfort in this arrangement, fans, cross-ventilation, and air conditioning, all three of them are used simultaneously to create a higher quality indoor-outdoor environment. Only the bedrooms are able to be fully sealed. And according to the owner, it's the first house that they've ever lived in where they didn't need air conditioning and never actually closed up the rooms. Slight breezes and sounds from the nearby nature reserve percolate into the center of the house, improving the overall air quality, combining inside to out, hot and cold, cool, humid, and breezy, merged together in a kind of thermal medium that plunges through the house. So when you're inside, you can actually feel the air pressure and the kind of breeze from the outside coming into the architecture. You can also hear birds in the outdoor, even though all the windows are closed. So it's a kind of strange experience. And here is that courtyard coming down as a funnel, and there is a water wall here that is used. Water pours out that not for decorative purposes, but actually to produce white noise, to mask sometimes when the urban noise is too loud. So air, its movement, and mixing about the center of the architecture drives the design, while illumination and a set of simple spaces configure the kind of organization of the architecture. So because it's a mid-block terrace house, the only way to get light into it is through basically carving kind of spaces on the top that allow light to come in on the side. So you can see this is the stair, and there's a series of skylights that also ventilate to bring light into the house, because you cannot cut a hole, because someone's house would eventually be onto the left and to the right. So the plan is super simple. It's just a bar of function and stairs. There's toilets there. And all the architectural effort is put into the section. Screens within the house allow for the thermal mass of the concrete to modulate temperature and cool the interior during the day. So in Singapore, the temperature drops a little in the evening, the house takes up that thermal mass, so it's a little bit cooler, and it will radiate that cooler temperature out. It kind of produces a thermal drag in the morning, so it keeps the house cooler for a longer period of time. Again, as I mentioned, cross-ventilation spans the full length in the plan. The house was built by a team of Chinese contractors who didn't speak any English, and my Mandarin is really terrible, meaning it's non-existent. And like many of projects in Singapore that I work on, this requires a tremendous amount of hand sketches, flexibility, goodwill, Google Translate, and sometimes a few bottles of Baijiu to smooth something out. The neighborhood is rapidly densifying and will soon be flanked by higher buildings to the left and the right, and you can see them already popping up. So this one had just popped up, those have popped up, those two are, and eventually all of these will be redeveloped. View of skylights and openings at twilight. Composed of a reduced palette of materials in board form and off-form concrete, contrasted to the timber. The simple terrace house, like the hut house, works with reduction as an architectural concept, reduction of materials, tones, and volumetric complexity to kind of amplify the presence of atmosphere and thermal comfort in a design that I hope is calibrated to the hot and wet equator. This is that looking up through the courtyard and that is completely open all the time. Okay, the next project that I'll show is for a building that's still under construction. I usually don't like to show work midway because you never know what you're going to get at the end. But I thought in the spirit of today's lecture, of the mid-scale, it was appropriate. It's a simple headquarters and represents a project in an urban context where the elevation is compressed due to its frictions with density, land use, and fire code. And this is the project there. The original building was designed by a local architect and was intended to have a curtain wall. And the very visions of modern architecture that my practice works very much against. So we were engaged to give an alternative vision while unifying the variety of complexities across the building facade. This is it just a few days ago. It's still being worked on. The main volume serves a variety of functions. There's 3 floors of naturally ventilated parking. There's another 3 floors of workshop areas that are also all naturally ventilated. There's 2 corporate floors, which are air-conditioned, but have operable windows at least. And I'll explain how all of this works. And the main thing, one of the main challenges, because of the density in relationship between the front and back buildings, was getting all of these, you can see them running up, all these little windows. They're not really windows, they're called fire access panels, and they're quite burdensome to work around. We see a display case on the left that puckers out from the building mass, while a gradient screen that encapsulates the building and unifies the complexity of, as I just mentioned, fire access, mechanical ventilation ducts, and while still allowing breeze permeability. And I just photoshopped it to give you a sense of what's coming. Taking clues from optical art, in this case, Bridget Riley's Orient 4 from 1970, a simple vertical that oscillates across the elevation creates a subtle but dramatic pattern. And we see this occurring in a kind of analog way on the building. It's a field that adjusts to accommodate all of that program and performance demands while creating a brise soleil to cut down the thermal load and allowing for breeze transparency. The facade is an aluminum assembly, welded and tapered vertically in a W profile that becomes almost textile-like. The edge profile, which you can see here, is radius as a single extrusion and was basically set up. The dimension was due to the die that the aluminum could be extruded through. And its light finish, and it's quite glossy, is designed to minimize thermal load while keeping the building as clean as possible. This was sent to me just a a few hours ago. And you can see the kind of oscillation between the outer envelope and the inner one, which is moving in and out. The inner envelope moves in a way, kisses the outer envelope right where we need the fire access panels. These will eventually be covered over. And then gets deeper to allow for a screening device here that operates horizontally, and of course the verticality of the pattern. Within the building, a larger two-story atrium links 7th, 8th, and 9th floor together in a continuous volume where daylight is filtered from above, and a dramatic stair cuts through this. The skylight and stair have gone in, and the work is going to surely keep me up at night for the next 6 months. The building operates as a kind of background building, sitting behind the showrooms in front. It's in a way I wanted to be reductive and simple, while the radius of the roof form integrates the building mass and elevation. Here, the east elevation looks like we ran out of money, but it's not true. It's a party wall, and eventually the neighboring building will build up right to it. So even though it looks like an object, it's really part of a larger urban context that will happen in the near future. So even at this large scale of 8 stories, projects in Singapore have this party wall configuration. In its nearby context, the site sits in early mid-century, mid-20th century building, and the reference and parallel between the two architectures is something that I was interested in engaging, and you can see that here, and then this is the new project that's almost done. The last project that I'm going to show is a simple factory building, and addresses two contradicting demands: the mitigation of tropical solar radiation, the openness, views, and transparency sought by the clients in a basic industrial warehouse typology. It was built by the hand of a team of 20 or so Bangladeshi laborers and a few Chinese on a very tight budget. It's a rough, crude building, yet one that utilizes simple design, and I hope with some intelligence, as a means to transform our expectations of an often neglected industrial typology. Like almost, it seems like all of my projects now, it's a mid-block terrace configuration. It's 1,000 square meter, located in a rapidly densifying neighborhood. So these are the existing buildings, and all of these are starting to be torn down and built much higher. It's located mid-block and synthesizes a series of important design strategies between open and closed, durable and adaptable, passive and active. And the hope is that the design is a resistance to the symbols of the temperate and the transparent, while providing the comfort of the tropics and the conditioned in an economical and efficient design. The architecture utilizes a simple 1.2 meter deep elevation fabricated in lightweight EIFS, affectionately known as Drive-It from those of you from the US, that wraps the building in section, and a bronze full-height window wall to reconcile this conflict between thermal opacity and visual and breeze transparency. The plan is predicated on a simple configuration, again like the simple terrace house, coupled with a sectional complexity. It's 4 stories, though 24 meters in height. These are 6 meter floor-to-floor height, so the height allows warm air to rise and to keep the workshop floors cool. The ground floor is cross-ventilated across its full length. And you can see that the envelope wraps both the elevation, the roof comes down, and also the underside of the carport. The core is placed on the west, on the party wall, to deflect solar thermal loading to the interior of the building proper. And it borrows much from the ubiquitous straight settlement shop house that is found throughout Singapore and what we can find in Malaysia. High ceilings, courtyard, trellis components of the facade, and of course, due to its plot, party wall construction are all simple yet important influences for this much larger project. The deep veil is composed of two parts. This is that EIFS assembly, and selected for its low thermal mass and lightweightness, so we don't have to add additional steel into the structure, and a lightweight window wall, which you can see here. Each component is very inexpensive and crude, and yet in their integration becomes a deep assembly based on a kind of singular performance. The facade design emerges as a solution that can accommodate multiple demands simultaneously. It encapsulates the primary mass, it calibrates views, limits solar heat gain, allows for ventilation, and also reduces background noise because of its quite textured finish. Again, the plans are really simple, even dumb. All the action is just put onto that core, and there's a courtyard in the center. Well, the architectural effort is put into the section and elevation. Now, I'd like to tell you that I spent months coding the perfect script to conceive of this elevation. I didn't. I looked to optical art, and as I've done in some of my other projects, in constructing the ideas in my favorite program, and it's called Illustrator. I spent a significant, we did spend a significant amount of time with the facade contractor to minimize the screen's thickness. And then all the profiles are tapered. We did the shop model so that everything was as we wanted. There were no shop drawings in this project, so it was kind of a direct-to-fabrication project. It was all done by computer control hot wire cutting. You can see the tapering in the assembly. So it produces some complex geometry to make that happen. Here it was assembled in a series of panels that were then hosted onto site. Ecotech was used to test our assumptions. It was quite a few years ago when I did this project. And we have something called ETTV, which is called envelope thermal transfer value. It's part of the code in Singapore, and it brings the with this envelope, it brings it to 25 watts per meter squared. This is a very low number. Already to achieve a kind of platinum is about 40 watts per meter squared. So we're almost half that. The facade pattern is purposefully designed to restrict views from the street obliquely, as you can see on the image on the right. It limits these exterior views in, while opening for more larger dramatic views at the top, which has a corporate office up there. It's also a kind of anamorphic pattern, which creates the illusion of a taller building. And it also has this kind of curious sense where people think that it's either out of GRC or concrete, but then when you get underneath it, you realize it's almost impossible because of the lightweightness. So it must be something else. So this kind of question of authenticity is something that we like to play with in the office. Here's the ventilation courtyard with 3 smoking balconies that poke out from it, creating a dramatic 4-story space. The roof terrace has screened views to a nature reserve jungle in the background setting, cut precisely at the kind of tree canopy's horizon line, maybe as a kind of ode to Le Corbusier's Bastiguier apartment. The screen continues wrapping over the mechanical areas on the rooftop. We have gray water collection from a series of rooftop collection areas that flush all the toilets and irrigate the property. And you can see the kind of basic structure of the themes. So we have all that ventilation, the party walls, the envelope, the open ventilated base, the service core, there's the courtyard. Simple detailing was applied to egress stairs and entry lobbies, believing that simple is always somehow intelligent. Here's the collection tray for rainwater. Simple reinforced concrete construction with minimum membranes. The building is almost entirely recyclable. When the building is redeveloped in the future, a typical occurrence in the Singapore context where the lifespan of a building is maybe 30 years. The overall result recalls the brise soleil of Vladimir Osipov's IBM building that I showed earlier, or his sunshade, though I would say temperately misplaced Carpenter Center at Harvard. Closer to Singapore, the facade alludes to the experiments of tropical building, recalling James Ferrier and Partners' Wing on Life building from 1975. This is in Singapore and one of my favorites there, yet made relevant to today through digital simulation and lightweight fabrication. The architecture is veiled deeply. It's hazy and atmospheric while creating a simple building for a banal building typology. It's a really rough building. Concrete is crude, algae grows on it, dirt accumulates on the off-white facade and stains the side elevations. But for me, it somehow looks good, it feels good, and it belongs on the equator. I just wanted to show a little bit of the work and maybe kind of go as a full circle to what I began. As an extension of my creative practice, I've spent the past 3 years, as Jason noted, traveling the equator as a wheelwright recipient from Harvard. And I've looked at 20th century, mid-century modernism that incorporate construction techniques, embody visions of architecture that confront density, development, and cultural identity across the equatorial. I've developed a body of research that has learned from this period, not as a historian writing history, but as a designer searching backwards to project forward, to draw and think through the hot and wet equatorial city, to uncover lost or forgotten histories, and to be inspired from a fantastic collection of material, formal, and technological techniques that percolate through this period. From the amazing Thomas Karsten Passage of Horror, which I showed earlier, to the Sequoia Center and its GRC parabolic facade, to the Joie Bus Depot by Artigas in the South American experiments and the big roof. This kind of curatorial, I would say even quasi-historical research folds back into my practice, driving the work forward. It has influenced how I look at history, architecture in the city, and for me forms a continuum of technology, aesthetics, and architecture calibrated to the atmospheres in which I operate. So we're drawing, representation, and research all work together as a contiguous medium, where the city, architectural scale, and the detail are interwoven with climate and atmosphere, not just as performance, but as a cultural and design medium that drives architecture. Thank you. Happy to take questions or comments.
All the fourth-year students have questions about the facade wall sections. Comprehensive studio questions.
Yeah. Mm-hmm.
I have several comments about your work, which I think is very refreshing. Part of the problem that we're having, especially in San Juan, Puerto Rico, is that we're emulating the architecture of the 1950s. Very much influenced by the architecture of German architects. I flew right there to study tropical architecture. And I think one of the problems is that the projects become aesthetics more than what you're doing. I think the advantage that you have is that you're doing research while you're designing, I think. Very different from the Department of Tropical Architecture, which my research, I don't think they were really doing. I think they got examples from previous projects that were already done under the discourse of modern architecture, not really tropical, and turning them into tropical. So I think that what you're doing is really exciting because you're doing both at the same time. The design as research, and I think research as design. So
Thank you. Yeah, I mean, I think it's a complex, it can become very stylized. And in Singapore, there are certain modes, or in Southeast Asia, there are certain kind of stylistic sensibilities. And there was, I mean, if we look at the period, say, from 50s to the 70s, where modernism was kind of embraced and also fundamental to the construction of statehood, then there was a kind of a turn against that because it was seen as kind of a trace back to the or back to Europe. And then architects started looking to the vernacular and kind of emulating the vernacular. And then there was something called like tropical modernism, which came in the 90s, which was basically kind of, in a way, it kind of became a dead end. It was basically fully glass buildings with just a few token screens on them, and they called this tropical modernism. I think that there's a lot more intelligence that we can look back, at least we can mine from this work in the 50s and to the 70s, because air conditioning hadn't taken over. And there's still a lot of work that we can learn from, but we don't necessarily have to totally emulate the aesthetics. So I think it's still a period that's ripe for architects to get inspired from.
For sections of the art design, we utilize natural ventilation and don't have any sort of air conditioning. Are the wind speed always constant, or are there times where there is no wind in the environment?
Let me just make sure I understand the question. The question was whether the wind speeds in Singapore are consistent or variable. It depends. So we have, for the uninitiated, we have a monsoon, kind of two monsoons. There's the northeast monsoon and the southwest monsoon. Temperature changes. It's like winter for me when it goes to like 26 degrees. It's already cold. But that's usually because the wind speed has picked up. But when it's between the monsoon, you get a period of really dead air. I mean, it doesn't move. So in my projects, the later ones, I definitely introduced fans. That's very important. And I didn't show this project, but we are working on a renovation of our architecture school that I was heavily involved in. And this, we worked with Transolar engineering, climate engineers, and we've developed something called a hybrid air conditioning system, which relies on just a little bit of air conditioning and then elevating the airspeed to about 1.5 meters per second. So you'll see all the design studios have fans in them. You cannot produce the comfort without that elevated airspeed, but it allows you to use a lot less energy because fans are a lot more efficient than air conditioning systems. So yes, we need some mechanical, let's say, polish to produce the comfort.
Sorry, and
Yeah.
like a follow-up on that, so with that system where you're introducing some mechanical along with the air conditioning, that would really be earmarked for that kind of deadest period, or would that be something that you would imagine being used year-round?
For the hybrid system that we developed is used all year round. It's coming in, basically it's dumping in air at 27 degrees, and then with a little lowering the humidity level, but it's 100% fresh air. There's no return, so the air quality is really good. There's no CO2, and then there's fans, and this would be used all the time. It has a little bit to do, comfort is all related to also what you're doing. If you're a student and you're working and, you're moving around, or your faculty members, you're producing a little bit more heat, so you got the temperature. But if you're home and you're sitting watching TV, or you're just sitting having dinner with your partner, your metabolic rate is usually lower, and it's a lot easier to produce. You don't need to cool it so much. I mean, we also have a problem in Singapore where air conditioning, I think, culturally is synonymous with wealth. So, like, if you go into a lecture theater in NUS where I teach, it's going to be like, it feels like 19 degrees. It's ridiculous. Because it is, air conditioning was a kind of symbol that you had made it out of the kind of tropical mangrove. And you could afford it, and you had the infrastructure, and your city had enough power to power the air conditioning, and you had enough intelligence and technicians to maintain it. So there is a kind of cultural lag, I would say, that continues when we're developing all this hybrid air conditioning system. There was a lot of resistance, even from faculty members, to it. They were really scared, like, that it's going to be too hot, that it's going to be uncomfortable, right? because they're used to a much colder operating temperature. But I think it has a lot to do with a kind of a kind of symbol, right?
One more question.
It's a bit weird, but I'm thinking like about this approach to designing performative architecture and how one would approach that when basically the information set that we have, basically climate patterns, sun patterns, and everything like that is kind of rapidly changing in this era of climate change and rapid weather changes, stuff like that, and how we can anticipate something like that and design for it. So I'm asking basically about how do we approach designing performative architecture when the information sets that we have are changing?
So I hope the lecture doesn't come across that I'm a total performance geek, because I'm not. Actually, I hate architecture that is like that, and there are people out there who like say, you know, as long as you've reached some level of comfort and energy efficiency, you've reached the holy grail of architecture. I think this is absurd. I'm interested in more that climate, or I'd like to use the word atmosphere, is a kind of medium that we design. So we design the atmosphere of this room. That's the role of architecture. And in the hot and wet environment, maybe we're designing not space, because space assumes like it's not there, like it's kind of absent. But in the tropics, like air is like thick. Like when I go outside, I feel it. I mean, it's a thing. So I think that's interesting. I mean, for me, it's interesting to think about designing that. And yes, it's hot and it's humid and it has all of these qualities, but I try not to think of them as like problems to be solved, but just as like things to work with. So if the climate or the atmosphere is changing over time, or we'll get hotter, or we'll have more cloud cover or less cloud cover, I mean, I think we just have to treat it not as a problem, but as something that we're engaging as architects. And yeah, I mean, of course, I'm looking a little bit. I mean, I argue with colleagues. I keep saying like the tropics is getting larger and bigger, and it's encroaching on the temperate. It keeps expanding, and maybe that's a great opportunity for people like you who are here in a hot and dry climate, and for me in a hot and wet one. That, you know, our expertise from this climatic context will become very valuable for other places.